Okay, thank you. So, as we uh, had announced, so I'll be speaking to it today about my experience on making optical character recognition systems for Telugu and other Indian scripts. Uh, and I work at the University of Hyderabad in India, and I work in a department which is called as the School of Computer and Information Sciences. Okay, my mail ID is there at the bottom, Atul.Negi at uhyd.ac.in. Okay, so been working on this for quite some time now. I think so, almost 2 decades, and a lot of colleagues and students have contributed. So my acknowledgements to Chakravarti Bhagwati, Narayanamurthy Kavi, both of them are my colleagues, and lots of other staff and students who had worked on this uh, on these works, and so they are acknowledged here. I think I hardly am in touch with any one of them now. Okay, so we'll start off with some introduction on optical character recognition systems. I think very generic thing, and then we'll get on to some aspects for Telugu. Maybe the contents here is not so accurate. I'll try to avoid some technicalities, which is from the image processing aspects. So, what do we do in optical character recognition? So, what we do is that um, we have some printed or written matter, and it is on some paper or cloth or some other physical medium, and then we take a high resolution or reasonably good resolution digital image, and that image, we pick up that image and we want to transform that the contents of the image into a symbolic and computer revisable and editable form. So each of these things is very important to note here. That is, it is symbolic, it is computer revisable, it is editable. So editable, as in we can select text on a keyboard and edit it. Okay, so like we take text, we can make it italic, bold, whatever. So what in very simple terms, it is that I have an image with a bunch of pixels. Okay, images are made up of pixels, and from the pixels we are converting it into this text. Maybe it is a Unicode text. All right. So that's what the OCR transformation is about. And how do we go about doing this? So, well, here I'm saying it's a Telugu document. So basically, it's the paper. It's a paper piece of paper. It could be any document, and then we are doing scanning. And so scanning, or these days, people are doing scanning using their smartphone cameras. But here, by scanning, we have worked mostly with the stuff which is on flatbed scanners. So that is, but these days I am also working. I have some research work on looking at scene text recognition. If somebody looks at my Google Scholar profile, recent recent publications are on the scene text recognition. So anyway, we get a digital image, whether it is through scanning or some kind of a handheld camera, and then we do a process which is called as binarization. In binarization, what we are trying to do is that we want to separate out the text part, the textual part from the background. Okay, so and then we try to do the word segmentation, which is that we try to find out what's the which set of pixels are words, which get together, and then from the words we pull out certain parts which are connected components. This is the image processing term, connected components. I hear somebody has maybe raised a hand or something. So should I be looking at that? Maybe I will ignore that and proceed with the presentation. So then we pick up a bunch of pixels which are related, and those are called as character complement. So now what happens is that when we try to replace, so we want to treat those pixels of the text with the size, same size, with what we have stored. So then there is a process which is called as a size normalization. Then we extract features and then we do classification, that is recognizing the characters. And then there is a post processing and encoding by which we end up with the encoded text. So more or less, this is the overall OCR process. And I'll try to walk us through this process. So there are plenty of applications of OCR. You have some task-specific readers, your general page readers, and so okay. Now, sorry. Let's try to get into a bit like what do you mean by character, optical character recognition. So if it is English, then no, we have the alphabet, and we make words out of these strings of alphabets. Okay, so and in the Indian scripts, it is so-called shallow orthography. So what we write is what we speak more or less, but the spellings, or rather, having to remember how some word is pronounced, that is not such a big issue in the Indian scripts. Okay, so character and orthographic units, these are quite different things. So in Indian scripts, we have the concept of akshara. Okay, so these are not syllables because the syllables are phonetic units, whereas the akshara are orthographic units. Okay, and there is a complex shape, and there are in the Indian scripts there is non-linear arrangement. It's not just as simple as going from left to right. There is some uh, there is some positioning which is above or below as well. We'll see that later on. Okay, so that's the thing. So that so so concept of character is not all that straightforward. Okay, so one of my friends, that is Narayan Murthy, he has developed this approach. Computer science people like to talk about states and state machines and grammars, formal grammars rather. So he has this approach of how you can produce some Indian script. So this what you see here. It's a production system wherein the V is a vowel, uh, and then you have to a vowel we may attach a vowel modifier, and or else we may have a consonant, and from the consonant we may attach a vowel matra. Okay, and then we may attach a vowel modifier. Okay, so like this, with this, these are different ways by which we'll be writing out something which is script. Okay, uh, so halant is actually consonant minus the vowel aspect. Okay, so that's uh, the a brief view of the script grammar. And then the question comes that how many aksharas. So by akshara it is that it is a combination of uh, a consonant or a vowel, and how they are combined, and they are written together as one orthographic unit. So for Indian scripts, how many aksharas could there be? There isn't really such a big such a limit. We can have if you take five consonant clusters and all the alphabet, so many large numbers can be there, but not more than 30,000 aksharas are found in the text corpora, and then of course almost 5,000 account for 99%. and but of course it is difficult to have this completeness. So in the now we get it on to Telugu script. So we have the phonetic aspects versus the orthographic aspects. So um, mantra is actually a vowel modifier. Okay, so and Vatu is actually a consonant modifier. Okay, and the building blocks which we have are the vowels and consonants, and you have simple as well as compound aksharas. Okay, wherein by simple akshara it's just a vowel or a consonant with a matra, and the compound uh, akshara has a simple consonant plus some matra and or one or more vatus. Okay, so such examples could be given here. Now OCR in Indian languages, we have lots of OCRs in Indian languages. We have for Bangla, Assamese, Devanagari, and some of the institutions where these have been built. Okay, so Malayalam is actually at Triple IT Hyderabad. This slide is slightly outdated. Okay, but inherently it is correct that at ISC they have developed the Kannada and Tamil OCR, uh, and Devanagari has been developed at ISC Calcutta, and a long time back at IIT Kanpur. Of course, CDAC Pune and CDAC Delhi also have been doing it for a while. And Gujarati OCR started off with University of Hyderabad helping out the MS University Baroda, but now University of Hyderabad is out of the Gujarati OCR, and it is only with the MS University Baroda. And always Gurumukhi has been at Punjab, and earlier it was with Thapar Institute, which is TIET, but now it is with the Punjabi University at Patiala. Now, why do we build OCR systems? So, in India, we have the vast literature, and to conservation and distribution of it in digital form is much better through the digital forms. Okay, so a lot of paper material is there, classical paper material is there, and one would like to conserve that those texts. So this is a very efficient form. And of course, OCRs could help people in business and other language applications. And another last thing, which is very going to be very useful, is especially for people who have difficulty in reading, is that we can start from a document and use an OCR and convert the OCR into code, into Unicode, and then that Unicode would be fed into a text-to-speech system, and that would convert the image to sound. Okay. Now, I believe this I've already covered. Um, so, how do you build a Telugu OCR? So, we look at the characters, and we tried some things which are called a structural approach, and there we compute image moments, and which we work with the size of the components. Then we applied neural networks where we use connected components, and then we apply training and recognition, or we do template matching, or wavelet multi-resolution analysis. So there are so many methods or approaches to building a Telugu OCR. Here, mainly my presentation will be showing something which is related template matching. So there have been plenty of efforts in Telugu that uh, the uh, very simplistic, just isolated character approaches were presented by Rajsekharan and Dikshit Lu. So Dikshit Lu is uh, my guru's guru kind of person. He's still around these days, though not so active as he used to be. Then at University of Hyderabad, 1995, we had some work wherein it was using neural networks, and not like today's neural networks, which is say deep learning kind of networks, but in those days we had different types of networks, optical networks, and so that was shown by these people. Then a practical system, which was a robust practical system, not just a one-off research demonstration, but a practical system was built by me and Chakravarti and with the help of our student Krishna. That was in 2001. And later on, there was a good work by Vasanta and Patwardhan. Vasanta was actually my MTech student, and she later on did some work, her PhD thesis on this Telugu OCR. So what's so difficult about doing OCR for the Telugu script as compared to other scripts? Especially there is a you have very good OCR systems for Roman scripts. Okay, but what are the difficulties are that the Telugu has a rounded nature, whereas English and other such scripts, they are having a lot of vertical strokes. Um, so Telugu doesn't have vertical strokes. And then other thing is that this Othulus and Matras. Okay, so these are the strokes which, or rather, these are the extensions, so the vowel modifiers and the consonant modifiers, which extend above and below the baseline of the text. Okay, so that is what creates problems. And then we have merging of glyphs. Okay, so when as I said, that we are having compositional nature of, and so that's why you are having the script down. So that's why then what happens is the symbols of one of the writing units also merge with the others, and that becomes very difficult to recognize. Okay, and then we have fonts with some kind of varied stroke thicknesses sometimes, so that also adds to the complications. So, how many basic symbols we have? So, the basic vowel sounds are just 16, and you have the simple consonants, which is called as Hallulu, is 36 symbols, and then every vowel can be modified with the matras. Okay, so uh, there is the matra stands for the long or short of the vowel. So that is how you get the vowel sound. So for each vowel, you can have a long or a short sound. So then that makes it uh, another 16. Then we have what is called as the half consonants. Okay, so as it is believed that every consonant has inherently a vowel in it, but when you remove the vowel, you are left with a half consonant. Those are called as vattus. Okay, so then there are 30 symbols of that. So now, what happens is in Telugu you can compose um, the characters and syllables from this above. So what I meant was by we are calling as akshara. So an akshara is an orthographic unit, and which will have some phonetic rendition, and that phonetic rendition could be built up from some composition of the characters and the syllables from the above. And so roughly we could have say like something like 5,000 or so theoretically. But then what we did in our Telugu OCR was that we tried to reduce the complexity, because it's not at all easy to build a OCR to try to recognize 5,000 different types of symbols. Okay, so what we did is we tried to reduce the complexity, and we tried to do the identification of the glyphs which are used in composition, and we could design a system wherein we were recognizing 400. We could try to recognize 400 symbols initially, and then as we had more expertise, we had reduced it to roughly about half of that also. Okay, so that is how we progressed. Okay, now some visual shapes. So the top row is the choose, that is the vowels. So you can see the shapes which is for e, u, like that, and then we have the consonants, and then the votus at the end. Okay. By the way, I'm not a native Telugu speaker. Okay? Shiv Prasad would be, and he can be very fast in seeing these symbols and being able to say what it is. So some more of the vattus, um, and then some more of the matras. Okay, so some of these things which we have is that one can identify. Say like for the e matras, this is the that is a short e and long e, or a short u, long u, like that. So you can see these matras, and then these are the so-called Reva-aksharas. So that is basically, these are the um, consonants which are without that is okay. I think I am not really an expert in this, but it is basically that is the uh, alant kind of thing, wherein it is the consonant without the vowel sound. All right. So I hope I'm right with respect to that. So now here we must remember that earlier we saw that we were going that we had Unicode, and then you were rendering it into visual form, right? Uh, earlier I mean, I think in our previous talks here. So that is, we were having the rendering from the code into some kind of a font or a script. All right. So here we are going the other way around. That is, we want to go from a font, a printed font and all, to get to a code. Okay. So there's not a very simple one-to-one kind of an approach. All right. So then we have here that we are saying that a glyph could be representing a single connected component, but it need not be a character. Okay, and a character can character and also code, these are two different things. Okay, so sometimes one character is a code, sometimes it is not. Okay, so as I have been saying, so that the orthography can be compositional with the vowel sounds and all that. Okay, so I think so. Now with that, we have some understanding about what is the script, um, and at the bottom right, we have certain examples of the um, aksharas, and that is the clusters of these vowels and consonants. Say, for example, Shri. Okay, Shri is an akshara, and it has E sound, the R sound, the S sound. So all this is combined here in this. Okay. So sometimes another sound which is another akshara which is called is the tra sound. Okay. So you have ta, the symbol ta, or through, like that. So like that you are seeing several of such aksharas here. So one of the research papers which we had, wherein we had a kind of a is a slightly more a detailed approach for doing the Telugu OCR. So here our overall process is that we take the image and we do segmentation. How do we do the segmentation? So the segmentation has two types of analysis going on. It's a lot of image processing kind of terminology here. So we take the image, we apply gradient magnitudes on that, then apply a half transform. On that, we apply uh, the recursive XY cuts. That is what RxYC stands for. And so from that, we decide that okay, where is the writing, and get a bounding box in the writing, and then we do binarization, find out the text, and find out the connected components, and we merge that. So that's how we can get the writing. And this is a very generic approach. It is robust. It can be applied. I'll show you some pictures. It can be applied on pretty complex backgrounds. And then after that, we do recognition. So in recognition, we get isolated characters, and we produce feature vectors. So that's why one has something like a 16-dimensional zoning vector, and then one can try to do a um, five nearest neighbor thresholded match, and you may get some candidates for the recognized characters. Once we get that, then one can try to zero in on which is exactly the right candidate by applying another feature extraction approach, which is cavity vector. And from the cavity vector match and the relaxation of the match, we can get to the recognized character. Or there are different ways that one can take nonlinear shape, and one can normalize the nonlinear shape and match it with respect to templates, and then we get the recognized character. So it's a really different ways of getting to the recognized character. So this is an example which has been taken from a magazine. Uh, so in India we have India Today. Originally the magazine started out in English, and then later on it is now in various Indian languages, including in Telugu. So this top right you see is the input image, and in this input image you can see that it's an image of a girl, and then the text which snakes around the picture. Okay, the text is snaking around the picture. So that is not good for an OCR system, because OCR systems are relying on a rectangle kind of assumptions of text. So then we need to separate out the picture and the text. Okay, so first part of processing is trying to show you that. So when we apply a gradient magnitude image, so then we are able to get some outlines of the text and the image, which if you are able to separate out, we are left only with some shapes, which are the only the textual shapes. So you get some kind of blobs, which you see in the bottom right picture. Um, so through this, we have isolated that where is the text. Okay, and the image part has been sort of almost thrown out, including the small piece of text. If you notice here at the bottom left, that is also found, and that is also located here. So that's why I say that this is a good work, that this throws out the picture and it retains the text, because an OCR is supposed to process only the textual parts. All right. So then, um, what it does is that it has taken the image at left, it has cleaned out the that where the text should be, and it has applied the recognition on that, and that's how it has been put up now here, rendered once again into the text. So that is how it is appearing now. Okay, and if you want to know how good is the recognition, then we need to read this text of the input on the bottom left, on the top left, and compare it with this recognized text here produced by the OCR. So then you will get to know that how correct is that, how correctly the OCR is recognizing the text here. So basically, that is one of the methods which we had for building the OCR. Okay. But that is not uh, the our production is OCR which we had built. at the University of Hyderabad, but this was a research demonstrator for sort of complex situations. And our main work was a template based matching approach, which you made use of such type of fringe distances. So here you can see, if you notice carefully on the picture on the right, it is there is a snaking set of zeros which go around, and there are other numbers which is arranged in a matrix form. So these the all the zeros are supposed to be representing black pixels. So if you put them together, you will be able to try to see one shape which is emerging out of that, and that shape is the Telugu letter A. Okay, so it is not the second A which is A, but it is the first A, that is A. Okay, so uh, so that is encoded here in this picture, which is 32 pixels into 32 pixels in size. Okay, so and there are some mathematical properties which make such kind of a arrangement good. We don't need blurring, and the distances are pre-computed and stored, and it helps with the matching. And such a matrix of 32 cross 32 is a template which we use for matching against other input and other characters. Which means all the other inputs need to be arranged and brought into this 32 into 32 format. And this thing we call it as classification by template matching. Okay, and what is our complete OCR algorithm is that we would read an input binary image, and we would segment the image into words, and we extract the connected components from each word. And once you found a connected component, you will normalize it to match the stored templates. We will compute the fringe distance map, and because you need to know which exact match is this, so then you have to compute the fringe distances to all the templates which are stored in the OCR. And each template is for one of the symbols to be recognized, one of the glyphs to be recognized in the OCR. So then, whichever is the template which is having the smallest fringe distance, we will say that we'll recognize and say that that is the recognized one, and then we will store this template codes. Later on, we have to take the template code, combine it, and look at it, and then we will instead of ISKI, now we are outputting Unicode. So that is how it would be. Okay, just to give you some visuals at the various stages of the process. So, for example, here there is some newspaper text which has been scanned, and this is a gray level image. So that's how the scanner would produce an output. And then after binarization, the same text would be looking like this. And you can notice also that a lot of noise is introduced once we do the binarization. So one has to binarize very carefully, and doing that also is an art. So once you do the binarization, then we do word segmentation. That we like try to isolate the words, and as you can see that inter-word spacing and inter-component spacing. These are two types of spacing. Usually, if you have good spacing between the one word and another, so then it is easy to identify each word. But that doesn't always happen. So this is a screenshot of what our OCR system tool was looking like, and this is a multi-purpose tool. We can do OCR system benchmarking, and in benchmarking, what you do is that you run the OCR on some text. Maybe most likely it is a known text, and we can compare what is the output, the text codes which is being produced by the OCR system, against the known text which is stored for that uh, image. Okay, so uh, this is the screenshot of the actual system which we had built. So this is showing that what other kinds of difficulties can come. So and it also tells you like what is a connected component. So here you can see that we have each of these Telugu characters, and there is a box around that. So this is what the OCR does. That it collects the text and then it tries to put a box around each of the um, uh, um, code, that is each of the units which it is trying to recognize. So and then for each such box unit, it is going to produce a code which is a glyph code in our OCR. We call it as a glyph code. Then what we do is that we are going to convert a sequence of glyph codes into the Unicodes. Okay, so then that will complete our process of doing the OCR. In between, some complications are there. That is, because we want to normalize, standardize. We have to standardize the size of the input. So if it is small, we'll blow it up. If it is large, we will scale it down. Okay? So then that is called as the size normalization. And then we have this approach where for every binarized image which is coming in, we'll compute the fringes, and this was useful because you have to match it fine. And there are methods which we used, which I will introduce later on, because to improve the recognition, there is a non-linear normalization approaches. Maybe I'll skip the details of this, but this visual we can tell you how what happens there. So basically, it tries to make certain parts of the character thicker so that the template matching process is enhanced and gets a better chance at recognizing. And we applied this on all the OCR glyphs, and then this is just a table which shows the regular glyph, the non-linearly normalized glyph, and then how it, so like that. We did that, and then that was helped to recognize that. Okay. And here is that when you're comparing the templates, you have to find out the distances. Okay. So this picture here from the screenshot is showing that how our program produces outputs, and the glyph code is there, and then what is the distance which is there of the input to that stored glyph. Okay, so the larger distance indicates a dissimilarity. So that and smaller distance, and the smallest one is said to be the one which is the recognized code. Okay, this is another type of method by which one can recognize. Okay, and this was also used in Bangla and Devanagari, and which we applied to Telugu. It was working well for Telugu as well. Somehow, for this work, we could not write a paper and publish it, but we have tried it out in our lab, and it was working. This is the part where it's a recognition. If we want to produce feature vector, so one can produce a feature vector in this manner by doing a zoning approach. So you take each character, and then that is subdivided, and in each of these rectangles, you try to compute that how many black pixels are there, and then the string of these black pixels taken together, and this is here is a matrix form, but this can be converted to a string as well, and then we may try to match these strings against what is stored in the data stream. And then here one slightly different concept which is there, which is totally unique to Telugu only. And this is a published work of mine with students. So, but this is not found anywhere else for Indian characters. So here we are looking at the background. So you have the character, and then we see that what is the empty space which is in that character, which we call as a cavity. and we encode the place or positioning of the cavity. So that gives us a cavity vector. So this is a structural feature in pattern recognition systems. We also have what is called a structural pattern recognition. So this is a structural pattern recognition approach, and that helps us to get or recognize that what is the character there. Okay. How is it useful? You can just see these two shapes in the box on the right. So these are quite different characters. Okay. Um, but uh, optically they are confusing because just the small difference here is what would make this into this. Okay, but then uh, there is for cavities approach. Now here this is a closed cavity, whereas this is open to the bottom. Okay, so although confusing, but once we go into the cavity vector, it is able to give us a way in how to distinguish. These are some details about how using nonlinear shape normalization we will be able to scale up and down and be able to recognize well. Okay. Now we come to the post-processing aspect. So in the post-processing aspect, what we have done is that we have isolated the glyphs and we have put the glyph codes. The numbers which you see here, these are the glyph codes, and we have to put them the glyph codes together to get a meaningful word. And once we get the word, we produce an output, and this is like an XML form, and that's the output, and that is how and this XML format can then be taken by a browser, and it can be applied, and you can sort of get a reproduction of what is recognized and compare it to a visual form of the image. Yeah, so that's how. Uh, so we did lots of work on segmentation, clustering, line segmentation in Telugu, and the recent work of mine is on the touching character segmentation and recognition. So I think I have already been speaking for quite some time here. Maybe I can stop my presentation and we could I take some questions and have some discussion.
Thank you, Atul. Thank you. I had no idea of a lot of these things and how complicated the Telugu language is.
Yes.
I don't think I can ever learn Telugu. That's it. I am 100% sure that there's many questions. I think we need a moment perhaps to, figure out what to ask you. But anybody feel free to unmute yourselves. Yes. Here we have, is that Craig yourself? Craig?
Yes, it is.
Yes.
I have a question. I'm aware that basic OCR that would just recognize the characters has lots of mistakes. For example, even with an alphabetic language, to distinguish something like English from Dutch or another language that uses the same characters. Are you applying a model of the words that are in Telugu, a language model, in your final processing?
Language model processing is not described in this approach because that involves collecting statistics of the language, which is here. This is it's like a cognitive approach only. That you see something and you try to produce a sequence of Unicodes. If you have a sequence of Unicodes, then there is a whole set of tools, language tools, which are there, which are very powerful, and like spelling correction and things like that. They can be applied, and you can get very good high quality output from it.
And is Telugu script used for multiple languages in India, or is it just the Telugu language?
So I know that we have ancient Sanskrit texts which are rendered into Telugu.
Mhm.
Yeah. So of course, Shiv Prasad is more qualified to speak on that than me. Mine is I'm essentially an engineer, so um, I don't have too much idea on that.
Okay, thank you.
Yeah.
Siva.
Yeah, in fact, Telugu and Kannada, these two have similar, very close,
Very similar.
very similar, scripts.
Yes.
And it's like, if you learn German, you might commit mistakes in English. It's like that because Telugu, when you read, I can read Kannada, but if I don't know Kannada, I cannot make meaning of it. But there are very close similarities. I think what Atul was talking about is applicable even to the other scripts, which has a lot of utility in terms of more cognitive kind of understanding of the languages and how it is perceived and how it is applied. See, what happens is when we are trained in the language in the childhood, we get, we are told how, there are a complete list of these things that are told. Like each Ottu or each other things, Haswa and long vowels or short vowels or short this thing, consonants and all that. There are big tables which were made, we were made to recite so that we understand the distinction between shorter and longer one. See, there is a very traditional kind of a teaching. Now that is almost dying in many of the modern, they're shortened. There are many words are removed or many letters are not there anymore, but they are written in a different form. It doesn't give the same meaning. In fact, this is what Atul was trying to talk about. I think that will help us to understand even the older texts. Older texts and the meanings of that can be much better understood. Like these are, you see, in fact, I don't know how far I'm correct, but what is said about the Telugu is it is called as Italian of the East. And somebody told me if it is Italian of the East, then it's difficult to, because some people who are not comfortable with Italian, they say that if that is the case, I don't think I should learn. This is a prejudice, but basically what it is suggested is it is a complex language, but at the same time, once you learn, in fact, this is true with all the Dravidian languages. There are a lot of similarities in the Dravidian languages. Like Tamil, there are a lot of words similar, not in terms of the script, but the words that are used, you find a lot of similarities. Similarly, Malayalam is more Sanskrit based, like Telugu, more of vowels and less of consonants. Kannada is more of consonants, less of it. So you have similarity in the language structures and variations. So once we understand that, it becomes much easier for us to, because if I know one South Indian language, it's easy for me to understand the other South Indian languages. I can pick it up. So because there is a linguistic structure in that.
Shiv Prasad, you could also talk about the fact that classical South Indian music is everything is in Telugu. It is not in Tamil. It is hardly in Tamil. It is not at all in Kannada, but mostly it is in Telugu.
No. That's not totally true. Because Telugu, actually the founder of the Carnatic music, South Indian music, was a great saint from Karnataka, and that is Kannada language. In fact, we start with rendition to Lord Ganesh. It is composed by that saint. Similarly, Tyagaraja is another saint who has composed a large number of poems. You have also in Tamil, but they are all, interesting is they are all composed in Telugu. Most of them.
That's what I meant actually.
No, it is there. It is because in the South Indian, see, Telugu was the largest spoken language in Indian district as a language, not as dialects. So that is where, because Hindi, there are a lot of things are added into Hindi, because Bhojpuri and other things are added. So if you don't add all that, Hindi cannot be a largest language. But Telugu was there all over, and it's a mixed with others. There are rulers, there are other kinds of things, there are migrants, all over.
We can say it's a classical language. So
Yeah, it is. Why I'm trying to highlight on this is because all the South Indian languages have similarity in terms of structure, except Tamil is more closer to French in terms of expressions. We don't have certain words. We use, which is there in French, and it's not in the. So there is very interesting characteristics because it is also one of the ancient languages. You find very interesting scenarios. In fact, when I heard Atul's distinct first last time, I suggested because of that, because how complex things can be made into simpler, and one can even approach a language from that. This is what I felt very interesting. Thank you.
Thank you, Siva and Atul. Julie, you have a question.
Yes, thank you very much for your presentation. And I've always been kind of amazed when I look at the recombined forms, the combined forms, like I've seen it more in Devanagari, but I realize you have said that there were something like 5,000 different forms. And so I'm wondering, when you mentioned for the project of doing OCR, you reduced it down to, I think you said 500 and then down to 200. I'm just curious if you can say something, and I think you've been touching on this, but I'm not sure. What is the decision process for eliminating the ones, how do you choose which ones you're going to focus on?
Well, that is the engineering decisions in which you say that yes, your error rate will go up. So you'll make a wrong decision. You are compromising, and you're saying that yes, you will live with that higher error rate.
So, but do you not look at consonant combinations or consonant vowel and so forth combinations that are most commonly used in the language that have a higher frequency?
So exactly. That is the idea. That we will drop out those which are less used.
Yeah.
And we'll concentrate on those. So we have to collect statistics, and we'll concentrate on those which are more used.
And that must be difficult to collect those statistics before you have OCR.
That's been taking us quite some time. So it's
keeping your graduate students busy.
No, that's the thing which my colleague Narayan Murthy, he's been doing now for almost 2 decades. Yeah. Collecting texts and then counting those things, and he has collected, I think so, a few 4-5, I don't know, maybe at least 5 million words and things like that. And as Telugu is inflectional, okay, so you can go on concatenating words together and get new words and things like that. So yes, it's difficult.
So I'm curious, and forgive me if you already said this, but is the process, do you believe that the process of creating the functional OCR system will influence spelling in the future? Because will people start to use the the more available consonant clusters, or do you think that it's going to influence spelling in the future, have a new standard for spelling?
Yes, possibly, because what we have seen is that all the Indian languages have evolved to sort of eschew the more complex consonant clusters, because rendering it in digital form, or even pronouncing it, and many such things. So this is a recent phenomenon, because computers with these things that has made this change.
Yes.
Incidentally, Narayan Murthy, his mother tongue is Kannada, his colleague.
Yeah, yeah.
Which is very close to recognition of because we have the Telugu my grandfather used to write is very closer to Kannada script. There is a lot of change and dropped. That is what it made it much more different from this thing. But still, traditional writing was similar to Kannada. Very interesting.
Maybe it would take one another of our sessions wherein we start from, say, Pali or something, and then we trace out how things got separated out into Telugu and Kannada and things like that. So.
And additional question: do you know of any minority languages that are using the Telugu script, that they have adapted it to their own language?
Oh, all I can say is that there are plenty of dialects, and they all use Telugu as their script. Yeah, but I mean that's another big task actually, to go around to collect those things, and then so you can say broadly there are two distinctions of the geographical regions of Telangana and Andhra, so where vocabularies and things are different, but anyway they use the same script.
Yeah, Daya, yes, please.
Yeah. So, congratulations to Negi and his team. And it's a very fantastic work they are doing. So, regarding this question from Julie is this Telugu script is being used because a lot of our all Sanskrit text we have in Telugu script, and we read it very efficiently and perfectly. It suits well. And we're using this Telugu script for, as you were saying, for some minority languages also. Because, for example, I'm working on Gondi and Koya, because still the script is not finalized for Koya and Gondi finally, because so we are using Telugu script for Koya language. So I have developed poetry and stories, but still because we can't adapt because there is no existing standard script for so Koya Gondi. So I'm using Telugu script for it, and state government is also using Telugu script for those languages. So this is for your kind information.
That's really enlightening.
I'll add a little more. You see, minority community, especially the Muslims in Andhra region, they largely speak Telugu and use Telugu. Even in their, namaz times, the the Maulvi addresses them in Telugu, only except some Arabic things for one or two sentences after. Otherwise, it's all done in Telugu. You see, what happens is many of these smaller groups, it's difficult for them to develop, and many of them don't even understand Arabic. So they are taught in this language and they converse in that. In fact, we have excellent writers and poets from minority communities. That's because we can't distinguish in terms of the way in which they pronounce and whereas you will find in films that is shown as if they are spelling things in a very awkward way, like a European speaks Telugu, how it is shown, they will try to show that, which is absolutely derogatory. It is not. It is only to get fun out of somebody else's system. But otherwise, most of the minority groups, not only in Telugu, it is also true with Kannada. Because I know like Tulu and other dialects, it's a very large groups, but they all use Kannada script. So this is common because what happens is it also, as I was telling, it helps people to switch over from the minor languages into the major languages or dominant languages. So that's the advantage.
Thanks, Siva. Yada, you still have your hand up, but is there something else you want to share? Any more questions?
So I said what I have to say. Especially the beauty of the script is it can be adapted by any. You can write, for example, you can write Hindi or Tamil, whatever the language. So we can actually it reflects. We can so easily. For example, without knowing Tamil, you can't actually decipher Tamil. Just knowing the script because it has a lot of nuances. Without knowing Kannada, you can't read Kannada. But with Telugu, even without knowing the other language, through script, you can actually read it efficiently and correctly. Error rate is very less. Yeah, you can go ahead. So Negi ji and so we want to listen more from you.
You're muted, Atul, and Craig has his hand up.
Yeah. All I wanted to say is that whatever I have is not the state of the art because go to that, then state of the art is what is a very big thing which is called as deep learning networks. Okay, and now it's very coincidental that just today one of my PhD students is submitting a thesis for Telugu OCR, which is based upon the deep learning networks. So
wonderful.
Yeah.
Yeah. Craig, you have a question?
Yes. I wonder, do you have any statistics comparing this OCR method with other groups, academic or industrial, or I'm sorry, industry that have done the same OCR?
Yes. So what we have found is that thanks to our attention to the language, our efforts are better than others. In fact, there is a Google Tesseract OCR project. So Google Tesseract OCR project is a very generic and very ambitious one, where they want to build a OCR framework and sort of plug in linguistic information into that, and so that voila, you have OCR for every script, right? So that we at some time we have compared that against the Google Tesseract, and it was somewhat better. Okay, but now there is one big thing by which we can't compare ourselves with Google is that they have the world's they have the entire data from the world. We don't have that much of data, so we can't compete with them in the long run. But for the short term we were doing well, and I think so. I think with my students, um, uh, deep learning network approach, we are state of the art, and at a in fact there is a big difference now. As Julie has pointed out, that these statistics are of the letters and the combinations is difficult. So my student has worked on a word level OCR. So you try to, like human beings read words. So it is not trying to read letters. So we have a word level OCR, and that is doing fairly well. Different models are there on that, and of course, further development perhaps would be more along those lines.
Great, thank you.
Yeah.
Any more questions, comments?
Yeah, I just want to be, I'm very grateful for being given this opportunity, because having worked on it for so many years, um, to be able to present it to the language community, that has really thrilled me. So uh, yeah, and of course I'm participating and keenly listening to all the other talks. In fact, that uh, the Adobe related talk was very interesting to me, because I'm seeing the other side of things, that you're going from code to shapes on paper, and I'm doing the other way around. So that was good. Yeah, fine. Thanks for this opportunity. Thank you.
Very good, thank you.
Thank you, Atul. It was very enlightening and thought provoking for us, and you presented to us things that we just didn't know anything about. So we're very, very grateful. And of course, the recording hopefully will reach more audience, and your project will be seen a lot more. But thank you again. Thank you very, very much.
Thank you, Negi. It's so very exciting thing I'm listening to you today. So as a Telugu person, I feel so I'm quite excited and elated. So it's they have a good helping us in our way ahead. A lot of
Yes. So
so
congratulations.
congratulations.
Yeah, I have an ambition to tackle up some of my friends who are really rich, and have them to support an NGO. In
Oh,
that NGO, we will come up with an open source our OCR. Actually, because OCR was funded by the ministry, so we weren't really on head too much in making something which I can give away to everybody. But the thing is, that it's there from the ministry, PL ministry, and things like that. Maybe I'll search and get across. Um, and it was very cool for me while I was listening to the talk. I just typed Telugu OCR GPT into Google, and a huge number of my previous talks and their presentations turned up in SlideShare and other such places. So if somebody would like to look at some more stuff, they can just type that in, and they can look at that. And they'll get things which are very much more technical, in going into some of the difficulties, which is typical to OCR, and especially for Telugu OCR. That what happens is that for old documents, the print is running into each other. Okay, so the print, one letter is getting one. It becomes one black blotch, which is not having any white space. So how do you build a OCR which is going to recognize that? So then we have to split the shapes. So how do you split the shapes? So algorithms to split the shapes and then recognize things like that. We have also done some work on that, and the student of mine who is giving his thesis now, he has also worked on that, and we got interesting and good, encouraging result on that. Hopefully, with that we can come up with some industrial strength OCR, and which could be for Telugu, and lots of people could be using it.
Atul, please send me the link, and I will add it to the video so people can actually link to it.
Okay. Yes. I'll send it.
Thank you.
I have a follow-up question. I have assumed that there is only one form of the handwritten Telugu script. In other words, in English, for example, we can print and we can use cursive, which is going out of style. Young people are not learning cursive anymore. So, am I correct? You have one form?
There is only one form.
Yeah.
Yeah, there is only one.
Yes. But what happens as it happens in cursive? So when I'm writing by hand instead of print, so then there is a change in the shapes, which depends upon what if you are writing one letter now, and then there's the next letter. Okay, so depending upon that letter, you take a shortcut, the ligatures and such kind of things, So that is very complex, very difficult. So hopefully,
And varies to person.
and very exactly.
That is a very complex thing.
Yes.
See, I have one thing to add. In the traditional handwritten Telugu, it is considered as Golusurata, or that means it's a linked writing. Unless and until you are very well versed, in fact, all the documents written for courts and other things were in that language. Those writers are specialized in that. And reading that also requires some specialization. So when I'm writing, there is no gap in between letters.
Yes. Yes.
That is, I think that will be a real challenge if you can try and
Yes.
develop something for that.
Yes. So there are some people, they collected the ancient no, Tadapatra. What do you call Tadapatra in English? Palm leaves, writing on palm leaves, and there is another form. I mean, another medium that is on copper leaf. So these type of inscriptions are there. That would be having that type of run-on text, which Shiva Prasad is describing. That it's a continuous run-on text. No distinct. I mean, it's very difficult to get any word boundaries in that. And to add to that, in Telugu, you can sort of in it's because it's inflectional. So the guy who was watching the kite could be made into one word. So it's like Vadu is the person. Okay, so guy watching the kite, maybe I don't know enough Telugu to make it into one word, but Shiv Prasad can say it is possible, right? Yeah. So now you can imagine that how difficult that would be. But it's yeah, and it's also a challenge. It's interesting that how we can try to attack that.
Oh, thank you again. Thank you so much. And congratulations on an excellent presentation.